Welcome to my YouTube channel. This is A Square Maths Made Easy Academy talking. In my today's video, I'm going to be considering what we call integration by parts. So the question is, when is a question said to be integrated using by what parts? Like in my previous video 3 months ago, I was able to talk about integration by substitution, which I would like so many of you to watch it. If you watch it, I'm telling you, you will enjoy it. And it will now lead you to what we call integration by what part. Now, any question that cannot be resolved by substitution method can be resolved either by part or by partial what fraction. Integration by part or integration by partial what fraction. Now, today I want to give you that of integration by what part approach. Now, when you talk about integration by part, it is just a combination of differentiation and what integration. Are you there? And we can only use that part when we might have analyzed that such problem cannot be resolved by what substitution what method. Let's take for instance now, if you are given a question like this, let's say integral of x exponential what x dx. Now, can you observe that this question cannot go by substitution what method? The reason is because if I'm to differentiate x, remember I said watch my previous YouTube on integration by substitution and equally differentiation. You will understand what I'm talking about. Now, what do I mean? If I should differentiate this x now, remember it will give me 1. And can you see that this one cannot and will never cancel what x? So which means such problem cannot go by what substitution what method. But had it been that I have a question like this, integral of x exponential x squared, are you with me now? Now you can agree with me that what I'm supposed to do now is to differentiate what x squared. In my previous videos, I was able to say much about this, but let me also do it for clarity what's sake. Now, what do you do in order to differentiate this? Consider the power. The power is what? 2. Then you multiply. Now, the next thing is to repeat the question. The question is x raised to power 2 and introduce minus what? 1. This minus 1 is the formula for what? Differentiation. Then if I continue, I will now say 2 times x will give me 2x. Now all raised to power 2 minus 1, which is 1. Then what you will do now, introduce that result at the denominator. Can you now see that x down will cancel this particular word x? Now this kind of problem is by substitution word method, which is my previous word video. That is how to identify it. But today what we are considering, just like I said, is what we call integration by what part. And this integration by part, the formula is being gotten from what we call differentiation by product rule. Now, what is a formula for differentiation by what product rule? Are you with me now? It is, remember the first thing we say, let y be uv. Are you with me now? Now, what am I going to do? I want to differentiate everything with respect to what? X. To get differentiation by product rule formula. Then if I differentiate y, it will give me dy over what? Dx. Watch my previous videos. Then it's now equal to, what is the criteria? You should put the first one constant, which is u, and differentiate the second one, which is v, with respect to what? X. It will give you dv over what? Dx. Then product goes with what? Addition. Now, what is the next thing? I will now put what? V constant and differentiate what? U with respect to what? X. It will give me du all over what? Dx. Now, this is what we call the formula on how to solve differentiation by what? Product rule. But why am I stating this particular formula? Is because we want to use it to prove the general formula for integration by what? Part. Now, having expressed this formula, I will now integrate both sides of the equation. How? I will now introduce integral of dy all over what? Dx. Then it's now equal to integral of u dv all over what? Dx. Then plus integral of what? V du all over what? Dx. Are you with me? Now, what is our target? Our target is to make u dv dx subject of what? Formula. How? This u is regarded as differentiation, and this dv dx is regarded as what? Integration. What will I do? I will now carry this to the left hand side. so that I will have integral of what? Dy over what? Dx. As this plus move to the left, it will give us minus integral of what? V du all over what? Dx. It's now equal to this one that we have made subject of the formula, which is u dv all over what? Dx. Are you with me now? Can you see that now life is easy? Now what do? We want to integrate dy dx. Now watch. Can you see that the coefficient of dy here is 1? Are you with me now? So which means our target is to integrate 1. And that 1 is called a constant. It's called what? A constant. Now, the rule of integration says, don't throw it away. Bring the 1, are you with me? And multiply with the variable. What's the variable here? Which is y. Are you with me now? So I have integrated this gentleman. So I will now say minus integral. Why this one I will not integrate is because this one is talking about differentiation. This one is talking about integration. So leave it what? Constant. I will have v du all over what? Dx. Then it's now equal to, this one is the formula, which is integral of u dv all over what? Dx. I want you to watch. 1 times y will give you what? Y. So which is minus integral of v du all over what? Dx. Are you with me? Then it's now equal to integral of what? U dv then all over what? Dx. So this is the general formula for integration by what? Part. But don't forget that we know what is exactly y. Talk to me, what is the value of y? The value of y is uv. I will now remove this y and put what? Uv then minus integral of what? V du dx is now equal to integral of what? U dv over what? Dx. This is a general formula for integration by what? Part. Are you with me now? So I'm going to be applying this formula to solve series of questions as far as integration by part is what concerned. But have it in mind, if I cannot solve it like, I cannot leave it like this, I can call it uv minus integral of u, v, right? This du over dx means u prime. Means what? U prime. What is the meaning of u prime? That prime means differentiation. Are you with me now? Then it's now equal to integral of u. dv over dx means v what? Prime. You can still write it like this. It's still talking about the same thing. Now, this is the formula that we're going to be approaching or using whenever solving problems like integration by what? Part. But before then, I want us to look at 1 or 2 examples. Are you ready? Remember that this is A Square Talking. Don't forget to subscribe my YouTube channel, and don't forget to click on the notification button. Are you with me now? And also don't forget to share it and comment about it. Then let's look at examples now. Now let's watch. Example 1 says this. Watch. The question says evaluate integral of x exponential x what? Dx. Look at this question. Evaluate integral of x exponential what? X dx. Now, when an integration is given to you, the first thing you are going to do, try to know whether it can go by substitution first. I have tested this, it did not work. The reason is because if I'm to differentiate this power now, x, it will give me 1. So I'll put 1 at the denominator. And this one can never cancel this x at the numerator. So which means it cannot go. Now, I want to use what we call DI method first, which is a shortcut. We call it DI method of solving integration by what? Parts. Are you with me? What did I say? DI what? Method. Somebody will ask, Sir A Square, what is the meaning of DI method? I want you to watch. It is very simple. Now, the word D stands for differentiation. Stands for what? Differentiation. And the word I stands for what? Integration. So which means D simply means what? Differentiation. What I say is D. D means what? Differentiation. While I means what? Integration. So which means when a particular question or problem is given to us, try to know which one you apply differentiation and try to know which one you apply what? Integration. Now, as we move ahead now, I want you to observe something here now. If you look at this, we are given something like this. Integral of x exponential what? X dx. Now, which one am I going to consider differentiation and which one am I not going to consider what? Integration. You consider x differentiation. Do you know why? By the time I keep on differentiating x, it will turn to 0. It will turn to what? 0. But expo, as you differentiate it, it will keep on reoccurring. Also, when you integrate it, it will also keep on what reoccurring. The reason is because expo is what? Expo. Now, let me use what we call DI method. Are you ready now? After DI method, I'm going to use the normal integration by part. Let us now compare the two and know whether the answer will be the same. We are watch. I will have here as differentiation. The next column is what? Integration. So the first one to use is x as differentiation, while exponential x, use it as what? Integration. Now let's go. Now what do we do? First we differentiate what? X. What does it differentiate what? X. X will give you what? 1. For those of you that may verge into my YouTube right now, may be wondering, how do we get what? X. When we differentiate x, the result is what? 1. Check my previous videos. But let me do it for clarity's sake. Now I want you to observe something. I want to differentiate what? X. Watch. What is the power here? 1. Differentiation, look at the rule or the principle. Consider the power. What's the power? 1. Then you multiply. Next is to repeat the question. The question is x raised to power what? 1. And finally, introduce minus 1 to the what? Power. Are you there? Then what do I say? 1 times x will give me what? X. Are you there? Then 1 minus 1 will give me what? 0. Then anything raised to power 0 by a lot of indices is what? 1. So that is why if you are asked to differentiate x, what is the answer? 1. Then let us now integrate expo. Now, integration is a comparison of both differentiation and what? Integration. What you are going to do now is that when you see an exponential function, just repeat it. If you integrate expo, it will still going to give you the expo. And the expo is called exponential what? X. Then it is not yet over. You introduce over. Are you there? Finally, differentiate x. X will give us what? 1. I'll put 1 here. And that is why when I divide, it will still give me what? Expo. Watch my previous what? Video. Now let's go. Now, when you're asked to integrate expo, expo is still what? Expo. Now let's continue. Now the next thing is to what? Differentiate 1. 1 is a constant. The answer is always what? 0. Then finally differentiate expo. Expo is still what? Exponential x all over 1. Why? When you differentiate x, it will give you what? 1. And exponential x over 1 is still exponential what? X. Now, since the differentiation has turned to 0, I don't need to continue again. What I'm going to do now is to get the answer immediately. Watch. The first row is plus. The second row is minus. The third row is plus. And even I have the fourth again, it will have been minus. Now, this is how it's been done. Then how do we get the answer now? We now inclined it like this. The first one, we multiply this. And the second one, we multiply the third one. And that is all. Now, let us pick the question. The question says integral of x exponential x dx, right? Is now equal to, well, let's go. I will now say x times exponential x. What is the answer? X exponential what? X. After that, what is remaining here? You introduce what? Minus. Finally, 1 times exponential x will still give you exponential what? X. Don't forget to put an arbitrary constant plus what? C. This is the final what? Answer. Using what we call DI method. So I can stop here, or if you observe this, I can still factorize. What is common? There is expo. There is what? Expo. Now factor exponential what? X. Open the bracket. What remains here now is x, right? Minus. Expo divide expo will give you what? 1. Close the bracket. Finally plus what? C. Wow, this is the final answer using what we call DI method. What did I say? DI method. But for clarity's sake, I want to use the general formula, which is integration by parts, to solve this particular problem and know if it will still give us the same particular what? Answer. So I'm using now integration by what? Parts. Are you with me now? Can you still remember the formula? Yes, we have proved it. What do we say is the formula? Integral of u dv over what? Dx is now equal to uv minus integral of v du all over what? Dx. Mind you that the question is we should integrate this. Look at what they said. We should integrate x exponential x what? Dx. The first one is your u. The second one is the v over what? Dx. That is how we approach it. Why do we choose to use x as u? Because when we differentiate x rapidly, it will disappear and turn to what? 0. So which means let's go now. So we are going to start by saying let u be what? X. Then what are we to do? Differentiate u with respect to what? X. Are you there? It will not give you the u all over what? Dx. Then it's now equal to, can we differentiate x now? Yes. What's the power? Invisible 1. Consider that 1. Multiply and introduce back the question x raised to the power of that invisible what? 1. Then introduce minus 1. At the end, we now say 1 times x will give us what? X raised to the power of what? 0. At the end, the value of the u over what? The x should be equal to 1. Are you there now? So next one is to move with the second one. What do we say is the second one? We now say let the v over the x be equal to exponential what? X. Are you there? Our target now is to cross multiply. Cross what? Multiply. Call this over 1. dv times 1 will give us what? dv. Then equal to the x times exponential x will give us exponential x what? dx. After that, we now integrate both sides of the equation. Are you there now? So can you see that the coefficient of the v is what? 1. So which means you are going to bring that 1 and multiply with the variable which is v. So 1 times v will give you what? V. So when you integrate the v, the answer is what? V. Then it's now equal to, can we integrate expo? I have said it already. Just bring down the expo. Then introduce over and differentiate the power, which will give you what? 1. If you differentiate s is 1, then divide it, what is the answer? Exponential what? X. Now, having satisfied the parameters, can we now go to the formula and substitute? And by so doing, we'll be able to locate the answers one after the other. I want you to watch this. Are you ready? So let's go back to our formula. Integral of x exponential x what? Dx. We said it is u dv minus integral of v du all over what? Dx. Well, let's substitute now. Do we know u? Yes. What's the value of u? U is given. What's the value of u? U is what? X. I will now put that x. Are you there? Next is v. I believe we have solved for v. What is the value of v? V is exponential what? X. We now put in exponential x. Then minus integral of what? V. What is v again? Exponential what? X. Then multiply by du dx. What is du? Du is already solved. Du is what? 1. So I'll put here 1. Don't forget to put your dx. Then let's continue. I have x exponential x minus integral. Watch this. 1 times exponential s is exponential x. The what? X. Finally, can you see that it is only one function that is remaining here? And that thing is called exponential function. Can we integrate it now? So that we now have x exponential x minus integrate expo. Expo is still what? Expo, which is exponential x all over. Then differentiate the power, which is x, it will give you 1. And you know actually that exponential x over 1 will still give you exponential what? X. And that is why we remove that 1. Are you with me? Finally, the symbol disappears. The x disappeared. Since it's an indefinite integration, go and watch my previous video. So what you should do, put an arbitrary constant plus what? C. Am I communicating now? So at the end now, can you see that the answer it produces is the same answer that we solve using DI method, but I can still factorize. What is common? Expo and what? Expo. I'll factor exponential x, open the bracket. What is left now? X, are you there? Minus exponential s divide exponential s will give you what? 1. Then finally plus what? C. And that is the final what? Answer. This is exactly how we solve problems like integration by what? Parts. Let us look for the second word example. I would like us to watch. Second word example. Now I want you to observe this. Watch everyone. Now this question is very critical and also simple, like the way we solved the other one. Don't forget DI method. DI method is for objective questions or professional exams that has to do with objective or CBT, computer based word type. Can we move to example word 2? I want you to watch. Now the question says, evaluate integral of 2x squared exponential 3x dx. Be careful. Look at this one now. Now this is also product function, x and exponential. Remember the law is to differentiate the power first and know whether that variable will cancel this variable here. And that thing is called what? Substitution method. Let's try it. If you differentiate 3x, it will give you 3. Can you see that there is no how x, there is no x there, so you cannot cancel this. So it means that such problem cannot go by substitution word method. It is by parts. But let us try it using what we call DI method. Don't forget the meaning of DI method. DI method means differentiation and what? Integration. So call this D and call this what? I, because we can still vanish this x as we keep on differentiating. Oh yeah, watch this. I will donate D here. I will donate I here. Then what is the value of D? 2x squared. The other one is exponential 3 what? X. I want you to watch. The first thing is to differentiate 2x squared. What do? Use the power. Consider the power. What's the power? 2, right? Use it to multiply these 2. It will give you 4. Just say 2 times 2. What is the answer? 4. 4 what? X. Raised to the power of 2 again, introduce minus 1. And you know that 2 minus 1 is still 1. So which means if you're asked to differentiate 2x squared, the answer is 4x. The answer is 4 what? X. Are you with me? Now if you are still confused, watch 2x squared. Now the first thing is to consider the power. What is the power? 2. Then you multiply. Repeat the word question. And the question is 2x raised to power 2. Introduce minus 1 to the word power. So at the end, you now have what you got. 2 times 2 will give you 4, right? 4 what? X raised to the power of what? 1. So it will now give you 4 what? X. And that's why we have 4x here. Then let's move to integration. Remember, I told you that expo is expo. Write down the expo first. Exponential what? X. Introduce over. Are you there now? Then differentiate 3x. Differentiate 3x. What is the answer? 3. Are you there? How? This is 3x now. The power is invisible 1. Let's differentiate it now. Consider the power. What's the power? 1. Then you multiply. Repeat the question. The question is 3x raised to power what? 1. And introduce minus 1 to the word power. At the end, we now say 1 times 3 will give us what? 3. 3 what? X. Then 1 minus 1 is what? 0. Oh my goodness. Anything raised to power 0 is what? 1. 1 times 3 is what? 3. So which means exponential 3x by integration is exponential 3x all over what? 3. Let's continue. The next is to differentiate 4x.
Mike.